Welcome, YouTubers, to another episode in my Grammar Heroes series. In today's video, I'm going to be working out 50 questions from a mathematics knowledge practice test that should help you prepare for the Armed Services Vocational Aptitude Battery, that is the ASVAB, the pre-screening Internet-delivered computer adaptive test, that is the PiCAT, the Air Force Officer Qualification Test, that is the AFOQT, as well as the Officer Aptitude Rating test. As always, I strongly encourage you to pause the video after I read each question, attempt to work out the problem on your own, and then resume playing the video to check your solution. As a reminder, on all of these tests, you are not permitted to use a calculator or a reference sheet, so as you work your way through the questions in this video, try not to use any of those resources. Similarly, I want to say this. In the description of this video, I'm going to include timestamps that are going to be associated with each question. Next to the timestamp is going to be the topic that the question's testing, as well as a link to a video where I discuss that topic in greater detail. So if at any point during this video you feel as if you're getting a little lost, just look in the description and there you'll find links to additional resources. Finally, I want to say this. As far as grading goes, here's how you want to think about your performance on this practice test. If you answer more than 80% of the questions correctly, that's outstanding, and chances are you're going to score very high on any of these tests. If you answer 70 to 79% of these questions correctly, that's also very good, and your chances of getting a high score on any of these tests is also pretty good. If you answer 60 to 69% of these questions correctly, that's about average. That means that you'll probably pass the test, but you're not going to get too great of a score. And of course, if you answer 59% or fewer questions correctly, that means you probably need to spend some more time studying in an effort to get better at solving these problems. So all that being said, let's go ahead and get started with today's video. All right, so as we can see, number one says, which of the following is the smallest prime number greater than 200? Our answer choices are 201, 205, 211, and 214. So to answer this question, we have to know two things. First, we have to understand what a prime number is. And we say a number is prime if it's only divisible by 1 in itself. So for instance, I know 5 is prime because it only has two factors, notably 1 and 5, which is itself. That is, 1 times 5 is 5. All right, so we have to actually expand on this idea and find a way to quickly determine which of these is the smallest prime number. And the way we're going to do that is we're going to make use of divisibility rules for 2, 3, and 5. Again, if something is divisible by something other than 1 in itself, then the number cannot be prime. And let's start with the divisibility rule for 2. The divisibility rule for 2 says this: if the last digit in a number is even, then that number is also divisible by 2 and therefore can't be prime. So let's look through our answer choices. The last digit here is 1. The last digit is 5. Those are both odd. 1, which is odd, and then 4, which is even. So according to the divisibility rule for 2, I know 214 is divisible by 2, and because of that, it can't be prime. All right, let's skip ahead a little bit, and let's talk about the divisibility rule for 5, since it's very easy to understand. The divisibility rule for 5 says this: if the last digit in a number is 0 or 5, then that number is going to be divisible by 5. So let's look through our answer choice one more time. This is 1. That's neither 0 or 5. Here we have 5. Since this is 5, I know 205 is going to be divisible by 5, and therefore it can't be prime. All right, so let's take a look at the divisibility rule for 3. It says this: if the sum of the digits in a number are also divisible by 3, then the number itself is divisible by 3. So let's take a look at 201. let's go ahead and sum the digits in 201. That's 2 plus 0 plus 1. 2 plus nothing is 2, plus 1 is 3. Is 3 divisible by 3? It is. 3 divided by 3 is 1. So since the sum of the digits in 201 are divisible by 3, I know 201 is also divisible by 3, which means it can't be prime. And by process of elimination, we know 211 is the correct answer choice. So number 2 says, what does the expression 6 factorial equal? So in case you didn't know it, a factorial symbol looks like this in mathematics. It looks like an exclamation point. So mathematically, 6 factorial looks like this. 6 exclamation point. And what a factorial says to do is take the number that you're given. So we're going to take 6, that was given, and you're going to multiply it by all the numbers less than 6 until you get to 1. So that's going to be 6 times 5 times 4 times 3 times 2 times 1. And now we actually have to work this out. And here's where being good at mental math is going to help you out tremendously. 6 times 5 is 30. 30 times 4 is going to be 120. And if you want, we can go ahead and work out 120 by 3 off to the side. That's 120 times 3. 0 times 3 is 0. 2 times 3 is 6. And 3 times 1 is 3. So this becomes 360. Now we have 360 times 2. You should know that's 720, but we can also work that off to the side. That's 360 times 2. 0 times 2 is 0. 6 times 2 is 12, so drop down a 2 and carry a 1. 2 times 3 is 6, plus 1 is 7. So this becomes 720 times 1. Anything times 1 is itself, so 720 times 1 is just 720. In other words, 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1, which when you work that out becomes 720. So the correct answer to this one is C, 720. Number 3 says solve the equation for x. We can see our equation is negative 3 times 2x minus 8 in parentheses equals negative 12. So not surprisingly, I'm going to start this one by copying this equation right here. We have negative 3 times 2x minus 8. And you will have scratch paper on the ASVAB, so I highly encourage you to use it instead of making mistakes by trying to work things out mentally. The first thing we have to do in this problem is take this negative 3 and distribute it here as well as here. That's the distributive property. Negative 3 times 2x is going to be negative 6x. Negative 3 times negative 8, well, that's a negative times a negative, so that's going to be positive 24 equals negative 12. So clearly, our goal is to rearrange this equation such that we get x equal to something by itself. So let's start by subtracting 24 from both sides. This will cross out here, leaving you with nothing but negative 6 on this side. And again, we're subtracting 24 from negative 12. So that's the same thing as this. 12 plus 24, but we know our result's going to be negative. So 2 plus 4 is 6. 1 plus 2 is 3. This is negative 36. Now to get x by itself, we're actually going to perform the opposite operation here. This says negative 6 times x, so we're going to divide both sides by negative 6. This crosses out, leaving us with x equals a negative divided by a negative is going to be a positive. 36 divided by 6 is 6. So the answer to this one is x equals 6, which we can see is D. If you wanted to, you could quickly check your work on a problem like this. Again, here's our original equation, negative 3, 2x minus 8 equals negative 12. We now know if we did our work correctly, x should be 6. So in place of x here, we can go ahead and plug in 6. This becomes negative 3, 2 times 6 minus 8. And my pen is starting to act up here a little bit. Bear with me. equals negative 12. Let's go ahead and work this out. 2 times 6 is 12, so this becomes negative 3 times 12 minus 8 equals negative 12. 12 minus 8 is going to be positive 4, so this is negative 3 times 4 equals negative 12. Negative 3 times positive 4 is going to be negative 12. And does negative 12 equal negative 12? It does. That's a true statement. And since this is a true statement, we know that x does in fact equal 6. All right, so number 4, as you can see, says convert 30 degrees Celsius to Fahrenheit. Use Celsius equals 5/9 times F minus 32. All right, so let's go ahead and get started by copying down this formula over here. It says Celsius equals 5/9 times, my pen is starting to act up a little bit, 5/9 times Fahrenheit minus 32. Of course, we were told that C is 30, so we'll go ahead and plug that into this equation, and it should be pretty obvious that we're going to be solving for F. In other words, when everything's said and done, we're going to have F equal to something by itself. So let's go ahead and plug in 30. This becomes 30 equals 5/9 times F minus 32. And the question is this: how are we going to clear this 5/9 in front of this F minus 32 to ultimately get F by itself? Well, to clear fractions, you can multiply them by their reciprocal. So we're going to multiply this by 9/5. And we're going to have to do that to both sides of this equation. As you can see, this 9 and this 9 will cross out, and this 5 and this 5 will cross out. So on the right-hand side here, we're just left with F minus 32, which is what we want. But that said, we still got to work this out. Right here, as you can see, we have 9/5 times 30. The question is this: how can we quickly work this out? Well, we can write 30 as a fraction by placing it over 1. And then we can say this: 5 goes into 5 one time, 5 goes into 30 6 times. And this becomes 9/1. 9 divided by 1 is just 9, times 6 divided by 1. 6 divided by 1 is just 6. And you should know your times tables, so 9 times 6 is going to be 54. So 9/5 times 30, in other words, is 54. Now let's add 32 to both sides to get F by itself. This crosses out here, leaving you with just F on this side. 2 plus 4 is 6. And 5 plus 3 is 8. So we can see F, our Fahrenheit, is 86 degrees, which is answer choice A. Number 5 says this: if 20% is equal to the fraction x over 60, then what is the value of x? So for this problem, we're actually going to work on translating this into an equation that we can then solve. More often than not on the ASVAB, you're going to have to convert percents to be in decimal form, and the decimal form of 20% is 0.2. All right, now we're going to move on. It says 20% or 0.2 is equal to. So is equal to means put an equal sign there. The fraction x over 60. So 0.2 equals x over 60. This problem tells you exactly what to do. And now that we've made that translation into an equation, let's go ahead and move it down here so we can solve accordingly. Again, we said 0.2 equals x over 60. It should be pretty obvious that we're going to be solving for x. So we want to get rid of this 60 from the denominator, which means we're going to multiply both sides by 60. This will cross out here, leaving you with just x on this side. And right here, we have 60 times 0.2. In an effort not to make a mistake, let's go ahead and work that off to the side. We have 60 times 0.2. That is to say, we're multiplying a whole number, 60, by a decimal, notably 0.2. If you haven't done this in a while, it can be a little bit tricky. But the goal is to clear the decimal from the question. And in this case, we can clear the decimal from 0.2 by shifting its decimal one place to the right. This becomes 60 times 2 with no decimals, albeit with one decimal to move back into the left at the end. So let's go ahead and work this out. You should know that 60 times 2 is 120, but let's work it out. 0 times 2 is 0, 6 times 2 is 12. Bring our one decimal back into the left. So we can see that x, in this case, is 12. And in math, it's customary to write the variable for which you solved on the left. So this is x equals 12, which is b. All right, so as you can see, number 6 says subtract 44x to the fourth plus 17x to the third plus x minus 18 from 54x to the fourth minus 33x to the third minus 28x squared plus 7x minus 6. So what we're doing in this problem is we are subtracting one polynomial from the other. And in case you haven't worked with polynomials in a long time, let me go ahead and tell you what those are. Polynomials are nothing more than expressions that have multiple terms. So here's one of our polynomials, and here's our second polynomial. So we're going to be subtracting this first polynomial from this second polynomial. And you have to set this one up correctly, otherwise you're going to get it wrong. So let's go ahead and work on doing that. First, I'm going to copy down this second polynomial, and as we can see, that's 54x to the fourth minus 33x to the third minus 28x squared plus 7x minus 6. And from that, we're going to subtract this first polynomial. More specifically, we're going to be subtracting all the terms in this first polynomial from all the terms in the second polynomial. So we're actually going to have to do subtract. Then we're going to have to put parentheses here to indicate that we're subtracting all the terms in this first polynomial. So let's go ahead and put those in parentheses now. We have 44x to the fourth plus 17x to the third plus x minus 18. And what this negative here says to do is distribute -1 to all the terms in this polynomial. So now that we have this one set up correctly, we're going to take this negative and distribute it here, 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 and finally here. So let's work on doing that. Let's go ahead and copy down this polynomial that we're not going to touch just yet. It's 54x to the fourth minus 33x to the third minus 28x squared plus 7x minus 6. Now let's distribute this negative. Negative times a positive is going to be a negative, so negative times positive 44 is going to be negative 44x to the fourth. Negative times positive 17x to the third becomes negative 17x to the third. Negative times positive x is going to be negative x. And then finally, negative times negative is going to be a positive. So this is plus 18. So now that we have this long expression, we have to simplify it by combining like terms. And like terms have the same letter variables raised to the same powers. So let's start with 54x to the fourth. As we can see, we have the letter variable x raised to the fourth power. And if we look through this expression, we can find that its corresponding like term is right here, x raised to the fourth power. So we're going to do 54x to the fourth minus 44x to the fourth. If you can't do that in your head, you can certainly work it off to the side. Again, 54 minus 44 should be 10, but if you can't do that in your head, it's 4 minus 4, which is 0, 5 minus 4, which is 1. So this becomes 10x to the fourth. Now that we've combined those two like terms, we can go ahead and cross them out. Let's move on to negative 33x to the third. Again, we're looking for the letter variable x raised to the third power now. And we can see that's right here, negative 17x to the third. We're going to be combining a negative and a negative, so we know our result's going to be negative. And if it's helpful, you can drop those negatives to combine these two. We have 33 and 17. 3 plus 7 is 10, carry a 1. 3 plus 1 is 4 plus 1 is 5. So this is negative 50x to the third. Let's go ahead and cross those out now that we've combined them. Moving on, you can see that we have negative 28x squared. So we're looking for x raised to the second power. And we can see that there is no like term in this expression, so we're just going to drop that one down as is. This will cross out now, and my pen's starting to act up here. It's probably tired of this problem already. All right, so now we have 7x. Technically, this x is raised to the first power, so we're looking just for the letter variable x, and we can see that's right here. 7x minus x becomes plus 6x. And then finally, we have 18 and negative 6. 18 minus 6 is going to be plus 12. And my pen is over this problem. So we're looking for this as our answer choice. 10x to the fourth. They all start out that way. Minus 50x to the third. So this one's plus. It's not right, but these are both minus. Minus 28x squared. This one's plus 28x squared. Plus 6x. This is plus 6x. This is plus 6x. Plus 12. Well, this one's minus 12. So we know the correct answer to this one is D. So number 7 says, if a parallelogram has a base of x plus 5 and a height of x plus 3, find its area. So how do you find the area of a parallelogram? It's very easy. It's just like finding an area of a triangle minus the 1/2. So to find the area of a triangle, it's 1/2 base times height. The area of a parallelogram is simply base times height. And thankfully enough, we were given both of those things. We were told B, or the base of this parallelogram, is x plus 5. Similarly, we were told H, or the height of this parallelogram, is x plus 3. So let's plug those in accordingly. This becomes x plus 5 times x plus 3. And since that's not an answer choice, that means we're going to have to actually expand this. And there are two ways to think about expanding this. Of course, there's always the FOIL method. But that said, the FOIL method is nothing more than the distributive property. We're going to take this first term and multiply it here and here. Then we're going to take this second term and multiply it here and here. So let's go ahead and do that. This becomes x times x, which is x squared, x times 3, which is plus 3x, x times 5 is plus 5x, and my pen is not liking this one. And then 5 times 3, which is 15. Let's go ahead and simplify this expression by combining like terms. There is no like term for x squared, so just drop that down. 3x and 5x is going to be plus 8x, and then this is plus 15. All right, so that's our answer, x squared plus 8x plus 15, which is answer choice C. Number 8 says, factor the expression completely. We have x squared minus 7x minus 18. So let me just copy this expression off to the side here. X squared minus 7x minus 18. The reason I copied my work off to the side is because I know a lot of people watch these videos using cell phones, and sometimes it's easier to see it when I write it in big letters. All right, so with that said, you can see that we're trying to factor a quadratic equation that has a leading coefficient of 1. So if this one's factorable, chances are it's going to look like this, x times x in parentheses. And now we're looking for two terms that multiply to negative 18 and add to negative 7. Well, I know that negative 9 times positive 2 is negative 18, and negative 9 plus 2 is negative 7. So just like that, we factored this one, and we can see that that is answer choice B. Number 9 says, evaluate the expression x to the third plus 4z minus 5 minus 3x when x equals negative 2 and z equals 4x. So in case someone's watching this on a mobile device, let me start by copying this expression down. We have x to the third plus 4z minus 5 minus 3x. We were told to let x equal -2 and z equal 4x. Normally, when you're asked to evaluate expressions, you simply plug in the numbers that were given into the expression and simplify accordingly. But while we can plug in -2, we really don't want to plug in 4x where we see z. That can lead to problems. So before we start plugging things in, let's take care of this z equals 4x. Well, we know z is 4x and x is -2. So we can actually take this -2 and plug it in right here. So this becomes z equals 4 times -2. And 4 times -2 is going to be -8. So in other words, x is -2 and z is -8. Now that we've done that, we can go ahead and substitute these values in accordingly. This becomes -2 to the third plus 4. What is z? Z is -8 minus 5 minus 3. What is x? X is -2. So now we have to simplify this, and the way you simplify expressions is by following the order of operations. Again, I remember the order of operations by the acronym PEMDAS, or please excuse my dear Aunt Sally. This tells you the order in which to simplify expressions or equations, and it says do what's in parentheses first, do exponents next, then do multiplication and division as they appear in your expression from left to right. That is to say, we treat those as equals. And then do addition and subtraction as they appear from left to right. That is to say, we treat addition and subtraction as equals. So if subtraction happens to come first, we would work that out, of course. All right, so as we can see, there are no parentheses to work on. So we're going to move on to exponents, and we can see we have an exponent right here, notably -2 to the third. And in case you haven't seen that in a while, that looks like this. -2 to the third in parentheses is the same thing as -2 times -2 times -2. And now let's just work this out. -2 times -2 is going to be +4. +4 times -2 is going to be -8. So this becomes -8 plus 4 times -8 minus 5 minus 3 times -2. Took care of our exponents. Now let's take care of multiplication and division as they appear in the expression from left to right. So this is -8. There's nothing there, so let's bring it down. And then we have 4 times -8. 4 times -8 is going to be -32. Then that's minus 5. And then we have multiplication here, notably -3 times -2. Negative times a negative is going to be a positive. 3 times 2 is 6. So we went ahead and took care of our multiplication. As you can see, there's no division to worry about. So now we're just doing addition and subtraction as they appear in the expression from left to right. So right here we have subtraction, -8 minus 32. So that's going to be -40 minus 5 plus 6. I don't know why my pen's acting up all of a sudden. All right, so now we have -40 minus 5 plus 6. Again, we do addition and subtraction as they appear from left to right. So this is -40 minus 5, which is -45 plus 6. -45 plus 6 is -39. All right, so the answer to this one is C, -39. All right, so number 10 says if the legs of a right triangle measure 6 centimeters and 4 centimeters, then how long is its hypotenuse? So we're working with a right triangle, and just to illustrate that, I'm going to make a quick sketch. And according to the problem, this right triangle has legs of 6 centimeters and 4 centimeters. Well, what are the legs of a right triangle? How do you identify them? Well, we know the hypotenuse of a right triangle is always directly across from the right angle. So this is our hypotenuse, which means that this side and this side must be our legs. And we can label those however we want. Let's call this one 6 centimeters, and we'll call this one 4 centimeters. And according to the Pythagorean theorem, if we know the legs of a right triangle, we can actually figure out its hypotenuse. So that's what we're going to use to solve this one. Again, the Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse of the right triangle. So this right here is our hypotenuse, so let's call that c, and let's label a and b accordingly. I'm going to call a 6 and b 4. Let's go ahead and plug those values in now. This becomes 6 squared plus 4 squared equals c squared. 6 squared is 36. 4 squared is the same thing as 4 times 4, which is 16, equals c squared. If you can't do this math in your head, you can always work it off to the side. This becomes 36 plus 16. 6 plus 6 is 12. Carry a 1. 3 plus 1 is 4 plus 1 is 5. So this becomes 52 equals c squared. Now let's take the square root of both sides to get c by itself. Again, the hypotenuse is just c, not c squared. So we're going to have to take the square root of both sides. This crosses out here, leaving you with just c. And c is the square root of 52. And if we look at our answer choices, we can see that 52, unfortunately, is not there. So there must be something that we can do with this square root of 52 to simplify it. Well, let's think about this. Can we break 52 down into something that's going to enable us to simplify this radical? Well, what is 52 divided by 4? 4 goes into 5 one time. 4 times 1 is 4. 5 minus 4 is 1. And then we drop down this. 4 goes into 12 3 times without going over. 4 times 3 is 12, so there's no remainder. In other words, we can write this as 13 times 4. Again, 13 times 4, as we just saw, is 52. And if you know your rules for radicals, you can actually break this apart like this. You can take this and make this square root of 13 times the square root of 4. The square root of 4 is what? Square root of 4 is 2. So this becomes 2 times the square root of 13. So we know c, or the length of this hypotenuse, is 2 square root 13. And that is answer choice B in this case. Number 11 says, find the circumference of a circle that has a diameter of 6 inches. Use 3.14 to approximate pi. So if you watch my video on circles, you would know that you can actually use two different formulas to find the circumference of a circle. Notably, you can use circumference equals pi times diameter, or you can use circumference equals 2 pi r. It really depends on what you're given. In this case, we were told that this circle has a diameter of 6 inches. So we know d is going to be 6 inches. And since we were given d, we're going to go ahead and use this formula over here. Let's go ahead and plug in 6 for d. And at the same time, we know we're going to be using 3.14 to approximate pi. So let's plug that in as well. This becomes 3.14 times 6. And now to solve this one, we actually have to do a little bit of arithmetic here. Notably, 6 times 3.14. And you might be saying to yourself, wow, that looks really weird the way you wrote it. And I'm going to fix that in just a second. As you can see, we're multiplying a whole number, notably 6 by a decimal. When you multiply something by a decimal, what you want to do is take that decimal and clear it. And to clear the decimal in 3.14, we're going to shift it 2 times to the right. And this is actually going to be rewritten as this. 314 times 6, albeit with 2 decimals to move back into the left at the end when we're done. Okay, we moved them to the right here, so we'll move them back to the left here once we work this out. 4 times 6 is 24, so drop down a 4, carry a 2. 6 times 1 is 6, plus 2 is 8. And 6 times 3 is 18. Bring our 2 decimals back in. 1, 2. So we can see that this is 1884. In other words, the circumference of a circle that has a diameter of 6 inches is 18.84 centimeters C. All right, so number 12 says, if a cube has one side that measures 3 centimeters, find its surface area. So for this problem, you simply have to know the formula to find surface area of a cube, and that's this. Surface area is equal to 6a squared, where a is one side of that cube. Again, in a cube, all the sides are going to be equal. So that means that you're finding the area of one face of the cube and you're multiplying it by 6. And let's go ahead and identify A. A in this case is 3. And let's plug that in accordingly. This becomes 6, 3 squared. According to the order of operations, we're going to do exponents before multiplication. So this is going to become 6. 3 squared is the same as 3 times 3, which is 9. And 6 times 9, you should know, is 54. Of course, we always associate area with squares. So this is going to be 54 centimeters squared, which is answer choice A. So number 13 says, what is the area of the shaded section of the figure below? The circles are identical and have a radius of 5 inches. In addition, they're inscribed by a rectangle. Use 3.14 for pi. So let's think about this. We want to find the area of the shaded section of this figure. The question is, how are we going to do that? Well, if we take a step back and look at the 3 shapes in this figure, you can see that we basically have a rectangle and we have 2 circles cut out of that rectangle. So to find the area of the shaded section, we're going to take the area of the rectangle. And from that, we're going to subtract the area of one of the circles, which I'm going to call area of circle 1, as well as the area of the other circle, which I'm going to call area of circle 2. So we can actually simplify this a little bit since we know circle 1 and circle 2 are identical. We can say this is area of the rectangle minus 2 times the area of circle 1. Again, circle 1 and circle 2 are identical. So how do you find the area of a rectangle? Of course, you should know that's going to be length times width. And how do you find the area of a circle? That's always going to be pi r squared. So let's see what was given to us in this problem. We know, according to the problem, that these circles have a radius of 5 inches. So we know r is going to be 5. So let's go ahead and plug that in over here. This becomes length times width minus 2 pi, and then this is going to be 5 squared. All right. Now, it's not so obvious what the length and width of this rectangle are, because we need to actually use the definition of radius to figure that out. Again, in case you didn't know, radius is defined as the distance from the center point of a circle to the edge of the circle. So let's put a center point right here. So from here to here is a radius. And we know, according to the problem, the circle has a radius of 5. So that distance right there is 5. If I were to extend this straight down, we would know that this is another radius, and this is 5. And as we can see, the width of this rectangle is this, 5 plus 5. So we know the width of this rectangle is going to be 10. We can do the same thing to find its length. Here to here is a radius. We know that's 5. Let's go ahead and put a center point right here. Here to here is another radius, and that's 5. And here to here is another radius, and that's 5. So the length of this rectangle is 5 plus 5 plus 5 plus 5, which is 20. So now we can go ahead and plug in those values, and this becomes 20 times 10 minus 2 times pi. And let's work this out. 5 squared is the same thing as 5 times 5, which is 25. And now we can start making progress in solving this one. 20 times 10 is 200. And what is 2 times 25 pi? This is going to be 50 pi. And according to the problem, we were told to approximate pi as 3.14. So let's go ahead and plug that in now. This becomes 200 minus 50 times 3.14. Of course, I'm going to have to work that off to the side because we're multiplying a whole number by a decimal. So let's do that. We have 50 times 3.14. And as we saw previously in this video, we want to clear this decimal. In this case, we're going to shift it 2 times to the right, and this is going to become 314 times 50, albeit with 2 decimals to shift back into the left at the end when we're done. So this is 0 times 4, which is 0, 1 times 0, which is 0, 3 times 0, which is 0. Before we start multiplication with this 5, we have to bring in a 0 placeholder. 5 times 4 is 20, so drop down a 0, carry a 2. 5 times 1 is 5 plus 2 is 7, and then 5 times 3 is 15. This is nothing plus this, so 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 7 is 7, 5 plus nothing is 5, 1 plus nothing is 1. Bring in our 2 decimals, 1, 2, so we can see that's 157. This becomes 200 minus 157, and my pen has given up on this one, but hopefully you haven't yet. 200 minus 157, which is going to be 43, that's inches squared. If you want me to work this off to the side, I will. We have 200 minus 157. Come on, pen, stop doing that. 0 minus 7 we can't do, so we have to look to the left to borrow. We can't borrow, so we're going to have to come all the way over here. This is going to become 1. This will become 10. Borrow one more time. This will become 9. This will become 10. 10 minus 7 is 3. 9 minus 5 is 4. 1 minus 1 is nothing. So that's how we got 43 inches squared there, which we can see is answer choice A. All right, so number 14 says find the product of the reciprocals of 1/2, 4, and negative 2 1/2. So before we can find the product of anything, we first have to determine what the reciprocals of these are. So again, we're going to be finding the reciprocal of 1/2, 4, and negative 2 1/2. So how do you find the reciprocal of something? Finding the reciprocal is pretty simple. It means you just exchange your numerator and your denominator. So in other words, the reciprocal of 1/2 is 2 over 1. And since 2 over 1 is the reciprocal and we're going to be using that for multiplication, I'm going to go ahead and put it in a box. What is the reciprocal of 4? That's a little bit more challenging to figure out. But that said, you should know you can write all whole numbers as fractions by placing them over 1. Now we can use the definition of reciprocal, which means you just exchange your numerators and denominators. So the reciprocal of 4 over 1 is going to be 1 over 4. And let's put that in a box. Now we got to deal with this mixed number here. So the first thing you want to do is convert this mixed number into an improper fraction. It's going to be negative. And to convert a mixed number to an improper fraction, you do 2 times 2, which is 4 plus 1, which is 5. So this is negative 5 over 2. Now let's find its reciprocal. How are we going to do that? Again, we're going to exchange our numerator and our denominator. So the reciprocal of negative 2 1/2, which is the same as negative 5 over 2, is going to be negative 2 over 5. And let's put that in a box. Now that we know our reciprocals, all we have to do is find the product of them. So that's going to be 2 over 1 times 1 over 4 times negative 2 over 5. And when you multiply fractions, it's actually pretty easy. You just multiply straight across. So this becomes 2 times 1 times negative 2 in the numerator over 1 times 4 times 5 in the denominator. 2 times 1 is 2 times negative 2 is going to be negative 4 over 1 times 4, which is 4, times 5 is going to be 20. And we can actually simplify this a little bit further if we wanted to. Again, it's going to be negative. But that said, you should notice that 4 and 20 have a common factor of 4. That is to say, we can divide both of them by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. So this is negative 1/5, which we can see as answer choice B. All right, so number 15 says solve the equation for x. We have negative x squared minus 5x squared plus 30 equals 0. So let's start by copying this one down. We have negative x squared minus 5x squared plus 30 equals 0. And at first glance, you may be thinking to yourself, can I factor this one? And you probably could factor this one. But that said, that may not be necessary since we have a lot of like terms that we can combine. You should see that negative x squared and negative 5x squared are like terms. So let's combine those to start. Negative x squared minus 5x squared is negative 6x squared. And this becomes plus 30 equals 0. All right, let's try to solve for x without factoring. So let's subtract 30 from both sides to get x by itself, or x squared by itself at this point. So this is negative 6x squared equals 0 minus 30, which is negative 30. Let's go ahead and divide both sides by negative 6 to get x squared by itself. This crosses out, leaving you with x squared over here. Negative 30 divided by negative 6. A negative divided by negative is going to be positive, so this is positive 5. Again, 30 divided by 6 is 5. Now let's take the square root of both sides, because that's going to enable us to cross out this squared, leaving us with x equals the plus or minus the square root of 5. Again, when you solve quadratics, there are usually two solutions, and in this case, we're going to say that B is the correct answer. All right, so that's that one. As you saw, we didn't have to factor it, even though it looked like it from the get-go. All right, so that's that one. So number 16 says, using 22/7 to approximate pi, find the area of a circle that has a diameter of 4/5 of a centimeter. Express your answer as a fraction. So for this problem, we're going to be finding the area of a circle. So we're going to use this formula at some point. Area is equal to pi r squared. Again, there are two formulas to find the circumference of a circle. There's only one formula to find the area of a circle. And as you can see, we're going to need to know the radius of this circle. But if we look back at our problem one more time, we can see that we were given the diameter of this circle. Notably, the diameter was 4/5 of a centimeter. Well, as long as you know that there is a relationship between the diameter and radius of a circle, this should be pretty easy to figure out. Again, a diameter of a circle is always twice as long as the radius. In other words, d is equal to 2r. And thankfully, we were told what d was. D was 4/5, so we can go ahead and plug that in right here. This becomes 4/5 equals 2r. And it should be pretty obvious that if we get r by itself, we'll be able to take that value and plug it into this formula over here and ultimately solve this problem. So to get r by itself, we're going to divide both sides by 2 next. This will cross out here, leaving you with just r on this side. And let's take a look at this off to the side. We have 4/5 divided by 2. Well, I can write 2 as a fraction by placing it over 1. And now what we're doing is we're dividing two fractions. And when you divide two fractions, you follow the algorithm keep, change, flip. This keep, or k, refers to this fraction in the numerator. You keep it as is. So we're going to leave that as 4/5. This change refers to your operation. You change from division to multiplication. And this f, this flip, refers to this second fraction. It means you flip it. So instead of being 2/1, it's going to be 1/2. And as we've seen in this video already, we're just multiplying fractions, so we're going to be multiplying straight across. This becomes 4 times 1, which is 4, 5 times 2, which is 10, and we have to reduce this. Both 4 and 10 are divisible by 2. 4 divided by 2 is 2, of course, and 10 divided by 2 is 5. So our radius is 2/5, and we can write it like this, r equals 2/5. Now, many of you could have figured that out without having to do all this work, which is great, but I still wanted to show the work in case you couldn't. So now that we know what our radius is, we can go ahead and plug it in over here. This becomes area equals pi. We were told to approximate using 22/7, so this becomes 22/7. And what was our radius? Our radius was 2/5, so this becomes 2/5 squared. Remember the order of operations. we do exponents before multiplication. So before we do 22 over 7 times 2 over 5, we actually got to square 2/5. And I'm going to do that over here. We have 2/5 squared. And when you square fractions like this, you actually square each of these individually. So this becomes 2 squared over 5 squared. 2 squared is 4. 5 squared is 25. So this becomes 22 over 7 times 4 over 25. And now we're just multiplying two fractions, which means we're going to multiply straight across. And this math is actually very easy to do mentally. 22 times 4 is going to be 88. And 7 times 25 is going to be 175. So the area of this circle is 88 over 175 centimeters, and area is always squared. So we can see that's answer choice D. If you needed me to, I can work this off to the side. We have 22 times 4. 2 times 4 is 8. 2 times 4 is 8, so that's how I got 88. And then let's do 25 times 7, if my pen will let me. 5 times 7 is 35, carry a 3. 7 times 2 is 14, 15, 16, 17. That's how we got 175. All right, so that is that one. If the perimeter of a square is 64 feet, then what is its area? So if you watch my video on finding the perimeter and area of quadrilaterals, you would know that if you know the perimeter of a quadrilateral, particularly a square, you can always find its area. Similarly, if you know the area of a square, you can always go back and find its perimeter. And let's think about why. So let's draw a square to start. And we should know some properties of squares, notably that this side is equal to this side, that side's equal to that side, and that side's equal to that side. That is, all the sides of squares are equal. All right. And what's more, we should know that we can label this as S. And if this side's S, this side's S, this side's S, and this side's S. Well, how do you find the perimeter of a square? To find the perimeter of any quadrilateral, you simply add up all of its sides. So this would be S plus S plus S plus S. In other words, the perimeter of this square is going to be 4S. All right, let's take a look at the problem one more time. It told us the perimeter of this square is 64 feet. So we know P is 64. We can actually plug that in right here for P. This becomes 64 equals 4S. And we can solve for S by dividing both sides by 4. This crosses out here, leaving you with S on this side. And if you can't do that in your head, you can always work it out the old-fashioned way. This says 64 divided by 4. 4 goes into 6 one time without going over. 4 times 1 is 4. 6 minus 4 is 2. Drop down this 4. 4 times 6 is 24. 24 minus 24 is 0. So we can see that S in this case is going to be 16. So S is 16. The question is this: how can we use the fact that S is 16 to find the area of this square? Well, let's draw a new square. Let me draw a better square for you. And if we know one side's 16, that means all the sides of a square are 16. So this is 16, 16, 16, and 16. How do you find the area of a square? Area of a square is equal to S squared. Well, we know what S is. S is 16. So let's just substitute that in. This becomes 16 squared. You should know what 16 squared is, but in the event you don't, this is the same thing as 16 times 16. And by working that out, we'll know what the area of the square is. 6 times 6 is 36. Drop down to 6, carry a 3. 6 times 1 is 6, plus 3 is 9. Before we start multiplication with this one, we have to bring in a 0 placeholder. 1 times 6 is 6. 1 times 1 is 1. Let's add these together now. 6 plus 0 is 6. 9 plus 6 is going to be 15. Carry a 1. 1 plus 1 is 2. So this is 256 feet, and area is always squared, if my pen will let me do it. So this one's area equals 256 feet squared, which we can see is answer choice D. So number 18 says, if a rectangle has a length of 12 inches and a width of 5 inches, then what is the length of its diagonal? So since we're dealing with a rectangle, let's quickly make one of those. And you should know some properties of rectangles, notably that this length is equal to this length, and this width is equal to this width. And we were told what each of those are. We were told that this rectangle has a length of 12, so this is 12 and this is 12, and a width of 5, so this is 5 and this is 5. We want to know the length of its diagonal. Well, what is the diagonal of a rectangle? It's from here to here. And when you draw a diagonal on a rectangle, you slice that rectangle into two right triangles. So let's go ahead and pull one of them out so we can see what I'm talking about. This is this right triangle right here, so we know this is 12 and this is 5. Well, what can we use? What do we know about right triangles that will enable us to figure out the length of this diagonal? Because clearly we can see that this right here is the same length as this. Well, we can actually use the Pythagorean Theorem to figure out the length of this hypotenuse here, which is C. And the length of this hypotenuse is the same length of this diagonal. As we've seen in this video already, the Pythagorean theorem says this: a squared plus b squared is equal to c squared, where a and b are the legs of the right triangle. Clearly we can see 12 and 5 are the legs of this right triangle, and c is the hypotenuse. And clearly c is right here. The hypotenuse, of course, is always directly across from the right angle. So let's plug those values in and solve for C. And it doesn't matter how you label A and B, so we can say A is 12, which means B is 5. So this becomes 12 squared plus 5 squared equals C squared. 12 squared, you should know, is 144. 5 squared is 25 equals C squared. And if you can't do this in your head, you can always work it off to the side. This is 144 plus 25. 4 plus 5 is 9. 2 plus 4 is 6. 1 plus nothing is 1. So this is 169 equals C squared. Let's go ahead and solve for just C now by taking the square root of both sides. This crosses out here, leaving you a C on this side. The square root of 169, you should know, is 13. So C in this case is 13. So we know this is 13, which means ultimately that this diagonal right here is 13 inches. So the answer to this one is C, 13 inches. So once again, we've had to solve a problem involving the Pythagorean theorem. So number 19 says, which of the following does not represent the sides of a triangle? As you can see, our answer choices have 3 sides of what could be triangles. And you should know that whenever you're asked to determine whether something is a triangle or not, and given its side lengths, you're going to have to use the triangle inequality theorem. And that says this. Let's first draw a triangle to illustrate this. Let's say our triangle had sides A, B, and C. The triangle inequality theorem says this: the sum of any two sides of this triangle cannot be less than the third side. In other words, A plus B, the sum of A and B, has to be greater than C. Likewise, A plus C has to be greater than B. And finally, B plus C has to be greater than A. If we plug in values and all these statements are true, that means that those sides could be a triangle. If, however, we fail at any point in testing this, we know that we do not have a triangle. And what's one way you can quickly determine that? Well, you can look through your answer choices and see which of these side lengths has the biggest spread. Right here we have a spread of 2 and 7, which is 5. That's not that big. Here we have 2 and 5, which is a spread of 3. That's not that big. Here we have 5 and 8. That's a spread of 3. And here we have 3 and 15. That's a spread of 12. So if I was a betting man, I would say these side lengths are not going to be enough to form a triangle. But that said, you always want to test it very quickly. So let's call 3A, 10B, and 15C. And let's start testing them. A plus B greater than C. So 3 plus 10 has to be greater than 15. Otherwise, we don't have a triangle. 3 plus 10 is 13. Is 13 greater than 15? It's not. So right away, this fails. And according to the triangle inequality theorem, we know that these side lengths cannot make a triangle. They're too short. Number 20, as you can see, says find the slope of the line that passes through the points 2, 2, and 5, 8. So here are our points, and I'll go ahead and copy those down. We have the point 2, 2, and the point 5, 8. We want to find the slope of the line that passes through these 2 points. So we're going to be using the slope formula, which says this. M refers to the slope, of course. It's equal to y2 minus y1 over x2 minus x1. And you might be saying to yourself, especially if you haven't found the slope in a long time, what are x1, y1, x2, y2? Where do I get those things? Well, those are values that you get from your ordered pairs. So this would be x1, y1. Again, ordered pairs come like this, x, y. But since we have 2 ordered pairs, I'm going to call this x1, y1, which means this is going to be x2, y2. Now all we do is have to plug those in. What's y2? It's right there, it's 8. What's y1? It's right there, it's 2. What's x2? It's right there, it's 5. What is x1? It's right there, it's 2. And after doing some simple math, we'll figure this one out. 8 minus 2 is going to be 6. 5 minus 2 is going to be 3. And 6 divided by 3 is 2. So the slope of the line that passes through these 2 points is 2, which is answer choice A. So number 21 says solve the following system of equations. We have negative 5x plus y equals negative 2 and negative 3x plus 6y equals negative 12. So there are 3 methods you can use to solve a system of equations. You can use the elimination method, the substitution method, and linear algebra. As it happens, I prefer using the elimination method. And before I talk about that, I just want to get these equations copied off to the side here. So we have negative 5x plus y equals negative 2. Then we have negative 3x plus 6y equals negative 12. The elimination method says this. Multiply either one or both of your equations by a constant such that when you add those 2 equations together, one of the letter variables, that is x or y, is eliminated. Let's think about how we're going to do that in this case. So I can see that if I multiply this top equation by negative 6, I'm going to have to take this negative 6 and distribute it here, here, and here. And when I get to here, negative 6 times positive y, that's going to be negative 6y. Negative 6y plus 6y will be 0, so the y letter variable will be eliminated. So that's how I'm going to eliminate the y letter variable. So to start, we're going to take this negative 6, we're going to multiply it here, here, and here. Negative 6 times negative 5x. A negative times a negative is a positive, so this is 30x. Negative 6 times positive y is going to be negative 6y. And negative 6 times negative 2 is going to be positive 12. Again, a negative times a negative is a positive. We're going to be adding that to negative 3x plus 6y equals negative 12. We're going to add these 2 equations together. 30x minus 3x is going to be 27x. Negative 6y plus 6y is nothing, so the letter variable of y is eliminated. And 12 minus 12 is 0. Let's solve for x by dividing both sides by 27. This crosses out, leaving you with x on this side. 0 over 27, or 0 divided by 27, is 0. So x is 0 in this case. Now that we know x is 0, we can take 0 and plug it in for x in either of these two original equations. And as it happens, you always want to pick the easier one. And it looks like it's going to be easier to plug in 0 in this top equation. So let's copy down this top equation. It's negative 5x plus y equals negative 2. We know x is 0, so we're going to substitute 0 in for x. This becomes negative 5. My pen is acting up all of a sudden. Negative 5 times 0 plus y equals negative 2. What is negative 5 times 0? Anything times 0 is 0. So this just goes away, and we're left with y equals negative 2. So there's our solution to this system of equations. And sometimes those solutions are expressed as ordered pairs. So this would be 0, negative 2, which we can see is D in this case. So at first glance, number 22 seems somewhat difficult, and it says if x equals y, simplify the expression 6 plus 2 times x minus y. Well, let's start by copying things down. We have 6 plus 2 times x minus y, and we were told to let x equal y. So normally, we're given values for x and y, but in this case, we were told to let x equal y. So that means we can pick our x and y values. So let's say I let x be 2. What is y? Well, we know this relationship right here according to the problem, so let's take this 2 and plug it in for x. This becomes 2 equals y. So we can see that if x is 2, that means y is 2. And now let's plug those values in. This becomes 6 plus 2. X is 2 minus y is 2. All right, let's work this out. Of course, we're going to use the order of operations to simplify this in the correct order. So this becomes 6 plus 2, which means we're going to work out what's in parentheses first. Again, please excuse my dear Aunt Sally. You do P or parentheses first. 2 minus 2 is 0. Now let's think about the order of operations one more time. We have, please excuse, there are no exponents. My dear, there is multiplication, 2 times 0. 2 times 0 is 0. So this becomes 6 plus 0, which is just 6. So the answer to this one is C, 6. You had to understand that no matter what you picked for x, y would be the same thing, which means that no matter what values you put in here, it's always going to be 0 here, which is always going to leave you with 6 as your answer. All right, so that is that one. That's a good question. So number 23 says if 3 to the x power equals 81, then what is x? So this one at first glance seems a little tricky as well, but let's take a look at it and see what we can figure out. We have 3 to the x power equaling 81. In other words, we have to plug in a value of x such that we get 3 raised to that power to be 81. Well, let's think about this one. What is 3 squared? 3 squared is 3 times 3, and we should know that 3 times 3 is 9. So clearly, x can't be 2, because 3 squared is 9, not 81. What about 3 to the third? That's the same as 3 times 3 times 3. And let's think about what that is. We have 3 times 3, which is 9. 9 times 3 is 27. So 3 to the third is 27. We can't use 3 to the third because that gives us 27, not 81. What about 3 to the fourth? That's 3 times 3 times 3 times 3. What's that give us? That's 3 times 3, which is 9, times 3, which is 27. What is 27 times 3? Let's work that off to the side. 7 times 3 is 21, so drop down a 1, carry a 2. 2 times 3 is 6, plus 2 is going to be 8, so this is 81. So we can see that 3 raised to the fourth power is 81. In other words, 3 to the fourth is 81. So we know x in this case has to be 4, which is D. So number 24 says this: graphs of the following equations are straight lines except. So for this problem, we're trying to identify the graph of a straight line. And if you look on my reference sheet, you'll see that on the very first page, I have three equations for straight lines. Notably this, ax plus by equals c. That's how one equation can look. The other equation is this, y minus y1 equals m times x minus x1. And then the other one is this y equals mx plus b. These are all equations of lines. And one thing you want to notice is that our letter variables, notably x and y, are all raised to the first power. In other words, straight lines are raised to the first power. If you have something that's raised to the second power, you have something other than a straight line. For instance, y equals x squared makes a graph in the shape of a parabola. So with those things in mind, let's look at our answer choices. X plus y equals 10. Well, that's of this form, so that's a line. Y minus 5x minus 2. Y equals 5x minus 2. That's of this form, so that's a line. Y equals x squared plus 5. Since we have a square, we know that this is a parabola, not a line. So the correct answer to this one is C. So number 25 says write an equation of a line that is parallel to y equals x plus 3 and passes through the point negative 4, 1. So for this one, you have to know things about parallel lines. Notably, you have to know that parallel lines have the same slope. So our line is parallel to y equals x plus 3, which means it's going to have the same slope as y equals x plus 3. And how are we going to identify the slope from y equals x plus 3? Well, let's put the slope-intercept equation right above it. Y equals mx plus b. We should know that m corresponds to the slope in this equation. So that means m's going to be right here. And for some reason, we don't see anything in front of x. Well, in algebra, whenever there's nothing in front of x, it implies that there's a 1 there. Again, 1 times x is just x. And in algebra, instead of writing 1x, you would just write x. So we know m in this case is going to be 1. And that's going to be for our line as well. And we know a point on our line is negative 4, 1. So the question is this. Using a slope and a point on the line, how can you write an equation of a line? That's pretty easy. We can actually plug these values into the point slope equation, which is y minus y1 equals m times x minus x1. We know what m is. And you might be saying to yourself, where do I get x1 and y1? Well, they're right here, x1, y1. So let's plug things in and solve. This becomes y minus y1's right there. It's 1 equals m. M is 1 times x minus x1's right here. It's negative 4. All right, so let's take care of this double negative right here. Double negative always becomes positive. So this is y minus 1 equals 1x plus 4. Let's distribute this 1 here and here. This becomes y minus 1 equals 1 times x, which is just x. 1 times 4 is 4. And as you can see, all of our answers are of this form, y equals. So let's go ahead and move this 1 over here via addition. This becomes y equals x plus 5. So the equation of our line, which is parallel to this line, is y equals x plus 5, which we can see is C. Number 26 says, if you deposit $4,000 into an account that earns 10% in annual interest and is compounded annually, how much money will be in the account after 1 year? Use A equals P times 1 plus R over N raised to the NT power, where A is the amount in the account, P is the principal, that is the amount you invest, R is your interest rate in decimal form, N is the number of times interest is compounded per year, and T is the time of your investment in years. So basically, this problem is nothing more than a test of your ability to identify things in this word problem, plug them into this equation, and then simplify the equation accordingly. So we have A, that's the total amount that will be in the account after our investment runs its course, equals P, the amount we invest, times 1 plus R over N to the NT power. And let's go through this problem one more time and identify things. P is the principal, the amount you invest. Well, we deposit $4,000. So P is 4,000. R is your interest rate in decimal form. We can see our account earns 10% in annual interest. So that's going to be 0.1. Again, 0.1 is the equivalent of 10%. Is compounded annually. So compounded annually means it's compounded once per year. And N is the number of times interest is compounded per year. So N in this case is going to be 1. It's compounded once per year. And T refers to time in years. We can see that we're going to leave this money in the account for 1 year. So T is 1. So with all those things identified, let's start plugging them in and solving. So this is going to become 4,000 times 1 plus R is 0.1 over N, which is 1. N is 1, and T is 1. So there's a lot of 1s, which means this is going to simplify pretty quickly. This becomes 4,000. Let's take care of what's in parentheses first. This is 1 plus 0.1 over 1. Well, anything divided by 1 is itself. So 0.1 divided by 1 is just 0.1. So this becomes 1 plus 0.1. 1 times 1 is 1. So this is 1. Anything raised to the first power is itself. So for example, 5 to the first power would just be 5. So we can see that this is going to be 1 plus 0.1 to the first power. So this is just going to be 1 plus 0.1. You should know that 1 plus 0.1 is 1.1. So this becomes 4,000 times 1.1. And all we have to do is solve this and we'll have our answer. So we have 4,000 times 1.1. And as we've seen in this video already, when you multiply a whole number by a decimal, you want to clear that decimal. So we're going to take this decimal and shift it one time to the right. This becomes 4,000 times 11. And once we work this out, we'll take our one decimal that we shifted to the right and shift it back into the left. 0 times 1 is 0, 0 times 1 is 0, 0 times 1 is 0. 1 times 4 is 4. Before we start multiplication with this one, we have to put in a 0 placeholder. 1 times 0 is 0, 1 times 0 is 0, 1 times 0 is 0, and 1 times 4 is 4. Let's add these together, although you can probably see the answer already. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 4 plus 0 is 4, and 4 plus nothing is 4. Bring our one decimal back in, so we can see that this is going to be 4,400. If my pen would work with me, $4,400 in our account after our investment ran its course. So the answer to this one is A. So number 27 says, what is the height of a triangle that has a base of 8 feet and an area of 16 feet? So in order to solve this one, we have to know how to find the area of a triangle. And we do that using this formula. Area equals 1/2 base times height. And let's see what this problem gave us. It said area is 16 square feet and it has a base, our B, of 8. So we can plug in B and A accordingly, which means we'll be left to solve for H. So let's do that. Again, the area of this triangle is 16 square feet. So let's plug in 16 here. This is 1/2. The base, or B, is 8. So this becomes 8. My pen is acting up again. 8 times H. So let's make this nice and easy. Let's do 1/2 times 8. 1/2 times 8 is 4. So this is 4 times H equals 16. And in case you need me to work this off to the side, let's do 1/2 times 8. As you can see, we're multiplying a fraction by a whole number. So you can write 8 as a fraction by placing it over 1, which means you're now just going to multiply straight across. This becomes 8 times 1, which is 8. 2 times 1, which is 2. 4 or 8 divided by 2, of course, is 4. So that's how I got 4 right there. Should be able to do that mentally, though. Again, we're solving for h, so let's divide both sides by 4 to get h by itself. This crosses out here, leaving you with h over here. 16 divided by 4 is 4, so we can see that h in this case is 4. So the answer to this one is h is 4 feet, and that would be B. So 28 says the solution of 4 times x plus 2 in parentheses minus 1 is greater than 5 minus 7 times 4 minus x in parentheses is. So to solve this one, we're going to be figuring out what the solution to this inequality is. Let's get started by copying down this inequality. So we have 4 times x plus 2 minus 1 is greater than 5 minus 7 times 4 minus x. The only thing you want to be careful with when you're solving an inequality is this. If you multiply or divide across this inequality sign by a negative, it's going to prompt you to change the direction of the inequality sign. So let's start working on this one. I'm going to take this 4, distribute it here and here. And at the same time, I'm going to take this negative 7 and distribute it here and here. 4 times x is going to be 4x. 4 times 2 is 8, so this is plus 8 minus 1, and that's going to be greater than 5. Negative 7 times 4 is negative 28, and negative 7 times negative x is going to be plus 7x. Let's start simplifying things to make this a little bit easier. This becomes 4x. 8 minus 1 is going to be plus 7. And we can go ahead and simplify this. Negative 28 plus 5, that's 28, 27, 26, 25, 24, 23. So this is negative 23 plus 7x. And now we want to start consolidating our x's on one side of the inequality sign and everything else on the other side of the inequality sign. So what I'm going to do is I'm actually going to subtract 7x from both sides to get my x's over there. This will cross out here. 4x minus 7x is going to be negative 3x plus 7 is greater than negative 23. If my pen will let me write that. Now let's get this 7 over here with this number via subtraction. This crosses out here, leaving you with negative 3x is greater than, what is 27, or what is negative 23 minus 7? That's going to be negative 30. And now we want to get x by itself, so we're going to divide both sides by negative 3. And right here, we just divided across the inequality sign by a negative. I divided both sides by negative 3, so that's going to prompt me to change the direction of my sign. This crosses out here, leaving me with x. Negative 30 divided by negative 3 is going to be positive 10. So the solution to this one is x is less than 10, and we can see that is A. All right, so that's how you solve inequalities. Again, as soon as you multiply or divide across the inequality sign by a negative, that's going to prompt you to change the direction of your sign. So that is that one. And sorry about that right there. My pen was acting up. I think my pen's starting to run out of battery. So sorry about that on this one. But this one is A. X is less than 10. And as you can see, we had to change our sign at this very last step where we divided across the inequality sign by negative 3. So as you can see, number 29 says solve the absolute value equation. We have the absolute value of 4x minus 15 plus 1 equals 18. So let's copy down this absolute value equation. We have 4x minus 15 absolute value plus 1 equals 18. And let me say this about absolute values. When you solve absolute values, you're going to have 3 possible outcomes. The first thing you want to do, though, to determine the number of outcomes that you're going to have is isolate your absolute value. So when you do that, here's how you're going to determine what your outcomes are. If you have the absolute value of something equal to a negative number, that means there's going to be no solutions. If you have the absolute value of something equal to 0, that means you're going to have one solution. And if you have the absolute value of something equal to a positive number, that means you're going to have two solutions. So the first thing we have to do, as I just said, is isolate our absolute value. And to do that, we're going to subtract 1 from both sides here. This will cross out, leaving us with the absolute value of 4x minus 15 equals 18 minus 1, which is 17. So in light of that, we know we're going to have two solutions, so we can cross out A and B. And let's go ahead and work on solving this. So at this point, we're going to break this apart to get our two solutions. And we're going to drop our absolute value bars. This is going to be 4x minus 15 equals 17. When we solve for x, that will give us one of our solutions. And then this one's going to be 4x minus 15 equals negative 17. That will give us our other solution. So now we're going to have to solve both of these equations. For x, let's add 15 to both sides. This will cross out here, leaving you with 4x. 17 and 15, we can actually work that out very quickly. 7 plus 5 is 12. Carry a 1. 1 plus 1 plus 1 is 3. So this is 4x equals 32, if my pen will let me write it. Let's divide both sides by 4 now. This crosses out. We should know that 32 divided by 4 is 8. So one of our solutions is 8. Let's add 15 to both sides in this one. This will cross out here, leaving you with 4x equals negative 17 plus 15 is going to be negative 2. Let's divide both sides by 4 now. This crosses out, leaving you with x equals negative 2 over 4 is negative 1/2. So our two solutions are x equals 8 and x equals negative 1/2, which we can see is answer choice D. So number 30, as you can see, says solve the equation for w. We have 2/8 plus 3/4 equals w over 5. So let's copy this down. We have 2/8 plus 3/4 equals w over 5. So in order to solve for w, we first have to combine these two fractions, notably 2 over 8 and 3/4. In order to add fractions, they have to have the same denominators. And as you can see, we have denominators of 8 and 4. That said, you should notice that 8 and 4 have a common denominator of 8. So in other words, as soon as these both have denominators of 8, we can combine them. And since this one already has a denominator of 8, we'll just copy it down as is. To write 4 as 8, we can multiply it by 2. We're also going to have to do that to its numerator. 4 times 2 is 8. 3 times 2 is 6. Now that these have the same denominators, we can go ahead and combine them. This becomes 2/8 plus 6/8, which is 8/8 equals w over 5. What is 8 over 8? That's going to be 1. And this becomes 1 equals w over 5. Again, 8 over 8 is the same thing as 8 divided by 8, and 8 divided by 8 is 1. To get w by itself, we'll go ahead and multiply both sides by 5. This will cross out here, leaving us with just w on this side. 5 times 1 is 5. So w, in this case, is 5, if my pen will let me do that. So w is 5, and we can see that that's answer choice B. All right, so that's that one. All right, so number 31 says if 3 and 2 are points on a line, calculate the distance between them. So we're given the points 3 and 2, as well as 7 and 8. We want to calculate the distance between those 2 points on a line. And to do that, we're going to use the distance formula, which says distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And you might be saying to yourself, well, where do I get x1, y1, x2, y2? We get those from our points. So this is x1, y1. This is x2, y2. So let's plug those values in. Start solving this. This becomes x2, which is 7, minus x1, which is 3, squared, plus y2, which is 8, minus y1, which is 2, squared. All right, let's keep working this out. 7 minus 3, of course, is 4, so this is 4 squared. And 8 minus 2 is 6, so this is 6 squared. This becomes 4 squared, which is the same as 4 times 4, which is 16, plus 6 squared, which is 6 times 6 are 36. 16 plus 36 we can do off to the side if you can't do that mentally. We have 36 plus 16. 6 plus 6 is 12, carry a 1. 3 plus 1 is 4, plus 1 is 5. So this is the square root of 52. And we've already seen how we can simplify this, but it's good practice to do it again. We're trying to simplify the square root of 52. And as it happens, we can actually break this down like this. This is the same thing as 4 times 13, which we can break apart to be the square root of 4 times the square root of 13. Square root of 4 is 2, so this is 2 times the square root of 13, or 2 radical 13. So the answer to this one is B. All right, so number 32 says simplify the following expression. You can see that we have x squared minus 9x minus 10 over x squared plus x minus 6 times x squared minus 4 over x squared minus 1. So let's start by copying this off to the side here. We have x squared minus 9x minus 10 all over x squared plus x minus 6. That's going to be times x squared minus 4 over x squared minus 1. So as it happens, we can actually factor everything. We can factor this x squared minus 9x minus 10. We can factor this x squared plus x minus 6. We can factor this x squared minus 4. And we can factor this x squared minus 1. So let's go ahead and do that. And it might be easier to start here. These are perfect squares, so that means they're going to look like this. This top one's going to be x plus 2 x minus 2. And if you work that out, you'll see you'll get x squared minus 4. This bottom one's going to be x plus 1, x minus 1. Now let's factor this top one out. It's going to look like this, x times x. And now we're looking for two factors that multiply to negative 10, but add to negative 9. And that's going to be minus 10 plus 1. Again, negative 10 times positive 1 is negative 10. Negative 10 plus 1 is negative 9. Let's go ahead and factor this other one out here. We're looking for two factors that multiply to negative 6, but add to positive 1. So that's going to be plus 3 minus 2. Plus 3 times negative 2 is negative 6. 3 minus 2 is positive 1. So now that we've factored everything, before we do this multiplication, we can start crossing things out. I can cross this x minus 2 and this x minus 2 out here. I can cross out this x plus 1 and this x plus 1 here. And now we're just multiplying fractions. This is one big fraction over here, and this is one big fraction over here. And when you multiply fractions, you just multiply straight across. So this is going to become x minus 10 times x plus 2 in our numerator over x plus 3 over x minus 1 in our denominator. And that is this simplified. So x plus 10, or x minus 10 times x plus 2, x plus 3, x minus 1. We can see that that is in fact A. So number 33 says simplify the square root of 9 over 16. So we're trying to simplify this. The square root of 9 over 16. You should know that we can actually break this apart like this. The square root of 9 over the square root of 16. The square root of 9, of course, is 3, and the square root of 16, of course, is 4. So the square root of 9 over 16 is 3/4, as you can see there. So that is that one. So number 34 says factor the expression completely. We have 2x to the third plus 6x squared minus 4x minus 12. So we have 2x to the third plus 6x squared minus 4x minus 12. It should be pretty clear that from 2, 6, 4, and 12, we can factor out a 2. So this is going to become x to the third plus 3x squared minus, this is going to be 2x minus 6. All right, so now that we've factored out that 2, we should be able to factor the rest of this via a method called grouping. And when you factor by grouping, you imagine that you split your expression in half. So I'm imagining I'm splitting this into two parts, x to the third plus 3x squared, and 2x, or negative 2x minus 6. I'm going to try to factor each of these individually. So what can I factor from x to the third plus 3x squared? I can actually factor out an x squared, and this will leave me with x plus 3 in parentheses. And now, when I factor this pair, I want to factor it such that I get the same thing in parentheses. So I'm actually going to factor out a negative 2, and this will become x plus 3 in parentheses. And now we're almost there. Let's go ahead and drop down one of these x plus 3's as part of our solution. And then the other part of our solution is going to be x squared minus 2. And we can rewrite this to be 2x plus 3 x squared minus 2. And that is answer choice A. So that's how you factor by grouping. That occasionally shows up on the test, so make sure you can factor by grouping. So number 35 says evaluate the expression 3/4 times 4/5 times 5/6 times 6/7 times 7/8 times 8/9. So we have 3/4 times 4/5 times 5/6 times 6/7 times 7/8 times 8/9. So as you should know, when you multiply fractions, you do nothing more than multiply straight across. So this is going to look like this. 3 times 4 times 5 times 6 times 7 times 8 in our numerator over 4 times 5 times 6 times 7 times 8 times 9 in our denominator. And as it happens, we can cross out corresponding values. So these 4's cross out, these 5's cross out, this 6 crosses out, this 7 crosses out, and this 8 crosses out, leaving us with 3 over 9. And you should realize that you can simplify this by dividing 3 as well as 9 by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So this is 1/3, which we can see as answer choice C. Number 36, as you can see, says if x is an odd integer, which of the following is an even integer? So in other words, we want to make x an odd integer, so we're going to let x be 3. 3, of course, is odd. Now, we want to figure out which of these expressions, when we plug 3 into it, outputs an even integer. And one way we can do that is simply by plugging 3 into each of them. So we have 2x plus 1. Again, we're letting x be 3, and we want this to output an even integer. So this is going to be 2 times 3 plus 1. 2 times 3 is 6, so this is 6 plus 1. 6 plus 1 is 7. 7 is odd, and we want an even integer, so we know this one isn't correct. Let's do the next one, 2x minus 1. Let's input 3 for x, so this becomes 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. Again, 5 is odd, so we know this one doesn't work. Let's go ahead and plug in 3 to this one now. X squared minus x. So this is going to become 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. 6 is even. So this one works, and therefore C is the correct answer. So number 37 says, what is the volume of a cylinder that has a diameter of 10 inches and a height of 20 inches? So for this one, you simply have to know how to find the volume of a cylinder, and that's using this formula. We're going to find the area of a circle, pi r squared, and we're going to multiply that by the height of our cylinder. So the formula to find the volume of a cylinder is pi r squared times h. We know what h is. H is 20 according to the problem. But that said, right here, we were given d equals 10. And as you can see, we need r. So we have to understand that there is a relationship in circles between diameter and radius. Notably, as I've said in this video already, diameter is always 2r. We know what our diameter is. It's 10, so this is 10 equals 2r. To solve for r, we'll divide both sides by 2. This crosses out here, leaving you with r on this side. 10 divided by 2 is 5. So this becomes this. Volume equals pi 5 squared times height, which is 20. Let's keep working this out. 5 squared is 25, so this is pi times 25 times 20. And let's work this off to the side so as not to make any mistakes. We have 25 times 20. 5 times 0 is 0. 2 times 0 is 0. Before we start multiplication with that 2, we have to bring in a 0 placeholder. 2 times 5 is 10. So bring down a 0, carry a 1. 2 times 2 is 4, plus 1 is 5. So this is 500 pi, and volume's always associated with cubes. So this is volume equals 500 pi cubed, which as we can see is A. All right, so that is that one. So number 38 says find the next term in the sequence. Our sequence is 3, 8, 18, 38, 78. So we have 3, 8, 18, 38, 78, and we want to figure out what the next term is. So when you're dealing with sequences, it's important to try to figure out the pattern that gets you from one step to the next step. To go from 3 to 8, I know we're going to add 5. To go from 8 to 18, I know I have to add 10. To go from 18 to 38, I know I have to add 20. To go from 38 to 78, I actually have to add 40. So let's see what's going on here. We go plus 5, plus 10, plus 20, plus 40. So each of these is doubling. To go from 5 to 10, that's times 2. 10 to 20, that's times 2. And 20 to 40, that's times 2. So by multiplying 40 by 2, we'll figure out what it's going to take to get us to our next hop. So what is 40 times 2? 40 times 2 is 80. So when we add 80 to 78, that will get us to our next hop. So that's 78 plus 80. 0 plus 8 is 8. 7 plus 8 is 15. So this is going to be 158. All right, so that is that one. I will say this. I made this look easy, but I've taken advanced calculus classes. And in those classes, you have to be able to write equations to represent a lot of different sequences. So I've had a lot of practice working on series and sequences. So uh, again, it may have taken you a long time to figure this one out, and you just have to sit there and struggle until you see the pattern. All right, so that is that one. Not an easy one, by the way. So number 39 says the sum of the first 7 prime numbers divided by 2 is. So as I've mentioned at the beginning of this video, I think it was question 1, a number is considered prime if it's only divisible by 1 in itself. So 2, for example, only has 2 factors, notably 1 and 2, therefore it's prime. So let's go ahead and sum the first 7 prime numbers. 2 is prime. 3 is prime. 3 only has 2 factors, notably 3 and 1. 4 is not prime. 5 is prime. 7 is prime. 8 is not prime. 9 is not prime. 10 is not prime. 11 is prime. 12 is not prime. 13 is prime. It only has 2 factors, 13 and 1. 14 is not prime. 15 is not prime. 16 is not prime. And 17 is prime. Is that 7? 1, 2, 3, 4, 5, 6, 7. We're going to divide that by 2. So let's quickly sum these, and I'm going to do this off to the side like this. I'm going to sum these, and I'm going to sum these. 7 plus 5, that's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that's 17 there. And let's sum these off to the side. We have 17, 13, and 11. 7 plus 3 is 10, plus 1 is 11. Carry a 1, and that's going to be 4. So this is 41 and 17. Let's add those together now. We have 41 plus 17. 1 plus 7 is 8. 4 plus 1 is 5. So this becomes 58 over 2. And if you can't do that in your head, you can always work it off to the side. We have 58 divided by 2. 2 goes into 5. 2 times without going over, 2 times 2 is 4. 5 minus 4 is 1. Drop down this 8. 2 times 9 is 18. 18 minus 18 is nothing. So 58 over 2 is 29. In other words, the sum of the first 7 prime numbers divided by 2 is 29, which is B. So number 40 says simplify the following expression and write your answer with only positive exponents. Our expression, as you can see, is this: 2w to the 4, v to the negative 5. That's all raised to the negative second power. So clearly, we're going to have to be able to work with the laws of exponents for this one. The first law of exponent you have to know is called the power rule, which basically means you have to take all the powers inside parentheses and multiply them by negative 2. And in case you're wondering, there's technically a 1 here. So let's work on doing that. This is 2 to the first. As I said, we're going to take 2 to the first, we're going to multiply it by negative 2. So this is 2 to the first times negative 2 in our exponent. And we're going to do w. This is going to become to the fourth times negative 2 in our exponent. And then v, again, we're multiplying those exponents, so that's negative 5 times negative 2. Let's go ahead and simplify this. This becomes 2. 1 times negative 2 is negative 2. W, 4 times negative 2 is negative 8. V, negative 5 times negative 2 is positive 10. And you don't have to write that positive symbol there if you don't want to. But we went ahead and took care of that multiplication. So what are we going to do now? We can't leave negative exponents in our answer. So if you haven't worked with exponents in a while, you have to realize this. When you bring a exponent across a fraction bar, it actually changes the sign in its exponent. So if I were to drop this 2 to the negative 2 down here, it would simply become this, 2 squared. All right. Similarly, if I were to take this w to the negative 8 and drop it down here, it would become w to the 8. And this is already v to the 10, so we don't have to touch it. That said, we can work out 2 squared. We know what that is. This becomes v to the 10. 2 squared is 4w8. So that is that one, and we can see that is answer choice A. All right, so number 41 says the expression the square root of 5 plus 6 times the square root of 20 reduces to. So we have the square root of 5 plus 6 times the square root of 20. So we can't do anything to this square root of 5 just yet, so we're going to leave that as is. That said, we can probably reduce this square root of 20 pretty easily. So let's go ahead and work on splitting it apart. We should know that 4 times 5 is 20, which means we could write this as this. 6 times the square root of 4 times the square root of 5. Well, what is the square root of 4? That's just 2. So this becomes square root of 5 plus 6. Square root of 4 is 2 times the square root of 5. What is 6 times 2 square root 5? That's going to be plus 12 square root 5. And my pen's starting to act up here again. And technically, there's a 1 in front of this square root 5 here. 1 square root 5 plus 12 square root 5 is going to be 13 square root 5, not 15. It's a long video. So the answer to this one is C, 13 square root 5. All right, so number 42, as you can see, says, what is the cube root of 729? In other words, that looks like this. What is the cube root of 729? In other words, what number times itself 3 times will give us 729? So that is how we find cube roots. Well, let's go ahead and figure out which of these is going to work. What's 5 times 5 times 5? 5 times 5 is 25, times 5 is 125. So I know 5 is not the cube root of 729. What about 7? Let's multiply 7 by itself 3 times. 7 times 7 is 49. What is 49 times 7? Let's work that out very quickly. 9 times 7 is 63. So drop down a 3 and carry your 6. 4 times 7 is 28, 29, 30, 31, 32, 33, 34. So we know that this is 343, which means 7 can't be the cube root of 729. What about 9 times 9 times 9? 9 times 9 is 81, so this becomes 81 times 9. 9 times 1 is 9 here. 8 times 9 is 72. So we should see that 9 times 9 times 9 is 729. In other words, the cube root of 729 is 9, which means B is the correct answer in this case. So number 43 says simplify the following expression. We have 17 minus 6 divided by 2 plus 4 times 3. So you might be asking yourself, how am I going to simplify this expression? There's a lot of operations going on here. Whenever that's the case, you always fall back on the order of operations, which I remember using the acronym PEMDAS, or please excuse my dear Aunt Sally. That is to say, we're going to do what's in parentheses first, exponents next, multiplication and division from left to right, that is, they're treated as equals, and then addition and subtraction from left to right, that is, they're treated as equals. Well, let's look through this expression, and we should see that we do have something in parentheses. So we got to start with parentheses. And now that we're in parentheses, these order of operations start over, basically. So in parentheses, we have subtraction and division. Clearly, division comes before subtraction. So we're going to do this division first, and then we'll take care of that subtraction. So this is going to be 17 minus 6 divided by 2 is 3, plus 4 times 3. We're still working in parentheses, but we only have one operation left, notably subtraction. So this is 17 minus 3, which is 14, plus 4 times 3. And right here, we have two operations left, notably addition and multiplication. Of course, we do multiplication before addition. So let's take care of that. 4 times 3 is 12. So this is 14 plus 12. And you should know that that's going to be 26. So the answer to this one is A, 26. So number 44 says, what is the decimal equivalent of 10 to the negative third? So we have 10 to the negative third. Well, as we just saw, when we have negative exponents, that typically causes us to write that number in the denominator of a fraction with a positive exponent. So the equivalent of 10 to the negative third is 1 over 10 to the third. And now we can express 10 to the third as this, 1 over 10 times 10 times 10. And you should be able to work that out mentally. 10 times 10 is 100. 100 times 10 is 1,000. So this is 1/1000th. And based on that, 1/1000th, you should be able to select the correct answer. But that said, let's say you're nervous and it's test day and you can't read this as 1/1000th and select the correct answer choice. You can also treat this as long division, notably as 1 divided by 1,000. And now we can actually work this out. We start by saying, how many times does 1,000 go into 1? It doesn't, so I have to add a decimal here. And I'm also going to have to add 3 0 placeholders. Once I add that decimal, I'm going to bring it up into my answer. I'm going to say 1,000 didn't go into 1, so I got to put a 0 here. Then I'm going to say, does 1,000 go into 10? It doesn't, so I'll put a 0 there. Does 1,000 go into 100? It doesn't, so I'll put a 0 there. Does 1,000 go into 1,000? It does. One time. 1,000 times 1 is 1,000. 1,000 minus 1,000 is 0. So 1/1000th in decimal form is 0.001, which is right here. And you could have read this as 1/1000th, and you could have realized that this is tens, hundreds, thousands, and that is the correct answer. All right, so that is that one. So number 45 says, simplify the following expression. We have x minus 2 divided by x squared minus 6x plus 8. And the way we're going to simplify this expression is like this. We're going to try to factor the quadratic equation in the denominator here. And then we're going to cross out any corresponding factors in our numerator and denominator. So let's see what that looks like. We're not going to touch our numerator just yet, so we'll write that down as x minus 2. And we're trying to factor this quadratic equation in our denominator, so it's going to look like that. Now we're asking ourselves, what two factors multiply to positive 8 but add to negative 6? That's going to be negative 4 and negative 2. Again, negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. All right. As I said, we can cross out corresponding values. We're going to cross these out right here. And that's going to leave us with a 1 in our numerator. So this is 1 over x minus 4, which is answer choice A. So number 46 says, in a triangle, if the second angle is 2 times the first angle and the third angle is 3 times the first angle, find the measurements of each angle of the triangle. So let's think about this one like this. We're working with a triangle here, and we don't know how many degrees each of the angles measures. That said, we can see that the problem refers to one specific angle each time. The second angle is 2 times the first angle, and the third angle is 3 times the first angle. So both of those make reference to the first angle. So let's call this first angle x, and let's fill this in accordingly. If this first angle is x degrees, that means the second angle is 2 times the first angle, which is 2x degrees. All right. And the third angle is 3 times the first angle. So if the first angle is x degrees, that means this third angle is going to be 3x degrees. It's 3 times this first angle. All right. And what do we know about triangles that's going to help us figure this out as well? Well, according to the triangle sum theorem, all 3 angles in a triangle will add up to 180 degrees. So angle 1 plus angle 2 plus angle 3 in a triangle has to equal 180 degrees. And as it happens, we have 3 angles. We have one angle that's x, we have another angle that's 2x, and we have a third angle that's 3x. So in other words, these 3 angles, x, 2x, and 3x, have to add to 180 degrees. So let's work on figuring out what we're going to do there. These are all like terms, so we can add them. X and 2x is 3x. 3x and 3x is going to be 6x equals 180. Let's divide both sides by 6 now. This crosses out here, leaving you with just x on this side. And you should be able to do this in your head. 18 divided by 6 is going to be 3. And then we just drop down that 0. All right, so we know x is 30. But what does that mean? Well, let's think about this. We can see that angle 1 is simply x. So angle 1 is x, and we know x is 30. So that means angle 1 is 30 degrees. Angle 2 is right here. It says angle 2 is 2x, and we know x is 30 now, so this is going to be 2 times 30. 2 times 30 is 60, so we know angle 2 is 60 degrees. And right here's angle 3. Angle 3 is 3x. We now know that x is 30, so this is 3 times 30. 3 times 30 is 90. So the measure of our angles are 30 degrees, 60 degrees, and 90 degrees, which is answer choice C. All right, so number 47 says, what is the sum of the interior angles of an octagon? On my reference sheet, I have a formula that shows you how to find the sum of the interior angles of any polygon. And that formula is this. The sum of the interior angles of a polygon is 180 times n minus 2, where n is the number of sides that that polygon has. So how many sides does an octagon has? An octagon has 8 sides. So n in this case is going to be 8. Let's go ahead and plug that value in accordingly. This becomes 180 times 8 minus 2. Of course, 8 minus 2 is 6, so this becomes 180 times 6. Let's go ahead and do this math off to the side. This is 180 times 6. 0 times 6 is 0. 8 times 6 is 48, so drop down an 8, carry a 4. 1 times 6 is 6, plus 4 is 10. So we can see that the sum of the interior angles of an octagon is 1080 degrees, which is C. So 48 says, what is the sum of all the numbers from 1 to 100? And you might be saying to yourself, when someone takes this test, do they really calculate this? Do they go 1 plus 2 is 3 plus 3 is 6 plus, and so on and so forth? Well, the answer to that is no, because you can actually view the sum of all the numbers from 1 to 100 as an arithmetic sequence, because again, we're going 1, 2, 3, 4, 5, all the way until we get to 100. And as you can see, we're just simply adding a constant of 1 to go from 1 to 2, 2 to 3, 3 to 4. So this is an arithmetic sequence. And to find the sum of an arithmetic sequence, we use this formula. Sum of n, where n refers to the number of terms in your sequence, is equal to n. N is the number of terms in your sequence, times a to the 1. That's the first term in your sequence, plus a to the n. That's the last term in your sequence over 2. Well, what is the first term in our sequence? Our first term's right here. It's 1. That's where we start summing things. And what's the last term in our sequence? It's right here. It's 100. So this is a to the 100, or a to the n, however you want to view that. So let's go ahead and fill these in accordingly. This becomes s to the 100 equals, what is n? N is 100. We are summing a total of 100 terms together. A to the 1 is our first term. It's right there. It's 1. A to the n is our last term, which is 100, all over 2. And by working this out, we'll be able to sum all the numbers from 1 to 100, which is nothing more than arithmetic sequence. So let's start working this out. This becomes 100 times 100 plus 1 is 101 divided by 2. If you can't do this math mentally, you may want to do it off to the side like this. 101 divided by 2. You should know that 2 goes into 101 a maximum of 50 times without going over, given that 2 times 50 is 100. 101 minus 100 is 1. Now, in order to keep going, we have to actually add a decimal here and a 0 placeholder. We'll bring that decimal up into our answer and drop down this 0 here. 2, of course, goes into 10 5 times. 2 times 5 is 10. 10 minus 10 is nothing with no remainder. So this becomes 100 times 50.5. And whenever you multiply a decimal by a power of 10, all you do is take that decimal and shift it to the right according to how many zeros there are in the power of 10. So in 100, there are 2 zeros. So that's going to mean we're going to take this decimal in 50.5 and shift it 2 times to the right and add a 0 placeholder. In other words, 100 times 50.5 is 5050, which is D. So number 49 says simplify the following expression. We have 3a over 2b divided by 6a over 5c. So this looks like this actually. 3a over 2b divided by 6a over 5c. That is to say, we're dividing two fractions more or less. And when you divide fractions, you follow the algorithm keep, change, flip. So this becomes 3a over 2b. That's our keep. We keep this fraction in the numerator the same. Then we change from division to multiplication. So we're going to change from this division to multiplication over here. Then we're going to flip our bottom fraction. So this is going to become 5c over 6a. Let's go ahead and do this multiplication now. This becomes this. 3a times 5c over 2b times 6a. And it should be pretty obvious that we can actually start simplifying this if we wanted to. We can simplify this like this. 3a goes into 3a one time. 3a goes into 6a 2 times. And now we have 1 times 5c, which is just 5c, and 2b times 2, which is 4b. So simplified, this is 5c over 4b, which is c. Number 50, which is the final question in this video, says evaluate the expression -3 to the 5. We should know that this is the same as -3 times -3 times -3 times -3 times -3. And now all we have to do is evaluate this. And I'm going to tell you this. If you have a negative raised to an odd power, such as 3, 5, 7, or 9, your answer is going to be negative. So I know -3 to the 5th power is going to result in a negative answer. But that said, I still have to do this arithmetic to figure out what that answer is going to be. So we're going to do 3 times 3 to start. -3 times -3 is going to be +9. Again, a negative times a negative is a positive. Now we got +9 times -3, which is going to be -27. -27 times -3, that's going to be positive. Let's work that out. 7 times 3 is 21, so drop down a 1, carry a 2. 2 times 3 is 6, 7, 8. So negative 27 times negative 3 is going to be 81. And now we have positive 81 times negative 3, which is going to be negative, but let's work that out. 81 times 3. 1 times 3 is 3. 8 times 3 is 24. So this is negative 243, which is answer choice D. All right, so that is it for this video. As you just saw, I worked out 50 questions from start to finish with no breaks, and I had headphone issues and pen issues during this long video, so I apologize for that in advance. That said, I wanted to make this video simply because I think it benefits you to see all these different topics back to back to back, because you may learn something in one problem that will help you solve another problem. As always, I hope you found this video helpful, and as usual, you're more than welcome to leave feedback in the comment section below. If you want to help my channel out, please consider subscribing to it. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.